Hi guys, let's do leaf similar trees. So consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. For example, in the given tree above, the leaf value sequence is 6, 7, 4, 9, 8. So they say two binary trees are considered leaf similar if their leaf value sequence is the same. So if we have two trees where the leaves would return this same sequence of numbers. So they want us to return true if and only if the two given trees with head nodes root 1 and root 2 are leaf similar. So in example 1, we have root 1 equals this tree, which is shown to the left, and root 2 is this tree shown to the right, and we would return true because, as we can see, their leaf nodes are colored blue here, and for tree 1, the leaf nodes are 6, 7, 4, 9, and 8, and for the second tree, our leaf nodes are 6, 7, 4, 9, and 8, and so since these are the same and in the same order, we would return true. And it doesn't really matter that they're not on the same level, as long as they're in the same order in all leaf nodes, then we know that it is, then that counts. So in example 2, we have these two trees, and we would return false because for the first tree, the leaf nodes are 2 and 3, and for the second tree, we have 3 and 2, and so since these are in different orders, it doesn't count, and so we'd return false. So also, a lot of you guys requested that I do dark mode, so I'm trying that out this time, and we'll see if we like it. Yeah, so for the algorithm, we're gonna want to do a DFS starting from the root of both of the trees. So I'll probably do that in a separate method so that we don't have repeated work. And we can just call the method for each tree, passing in each root. And in our DFS, we are going to check, so if our base case, I guess, is if our node is null, and if that's the case, then we would just exit the DFS because there's nothing to do, and probably return an empty list because we want a list to add all of the leaf nodes to that we're going to pass into our DFS, and then at the end we're going to compare if the two lists of leaf nodes are the same, and then we're going to also check if at our current node, if the left child and right child are both null, that's how we'll know that it's a leaf node, and if that's the case, then we'll add that to our list. So we can start by initializing our two lists. So we're going to do a list of integer for list 1 for the first tree, and we'll make that a new array list, and same thing for the second one. And also, sorry for the really unusual background recently, guys. I am traveling, so just bear with me. But I am trying to still put out content as much as I can right now. But sorry, I'm talking and typing at the same time, so now it's like I'm typing random stuff. Okay, so basically we're gonna pass in our root 1, which is our first tree, into our DFS and our list, and we're going to assign that to, like, we're going to set this list equal to whatever our DFS returns, which is going to be the list of the root, or of the leaf nodes. And then we're going to do the same thing for list 2. So DFS pass in root 2 and list 2. And then we're going to return if the two lists are equal. So list 1 dot equals list 2. And that'll be it for this method. And then we just need to do our DFS. So private, I'm going to return a list of integers because that's, we're assigning it to each list. And you don't have to do it this way, but I just like it this way because it's a little bit more explicit. So that I know like exactly what's going on. So we're going to pass in the tree node, and the list. Okay, and then first of all, so if you remember, we said if our node is null, then there's nothing to do, so we'll just return in the list, which should be empty. So if node is null, return the list. And okay, so then if the left and right child are null, then we know that it's a leaf node and we'll want to add it into our list. So if node.left is null and node.right is null, then list.add node.value. Okay, and then we'll do the same thing for the left node, and we'll pass in the same list, and the same thing for the right node. And I'll pass in the list, and then we'll just return the list at the end. So let's see. Perfect. All right, so basically, so our time complexity, if we think about this, is, so we do a DFS, right? Because, yeah, basically all we're doing here is calling the DFS, so all of our time is going to be in this DFS. And in this DFS, we are visiting, starting from the top node, the root node of whatever tree, we are visiting every single other node exactly once. So that's going to be O of n, where n is the number of nodes in the tree, but we're doing this twice, one for each tree. So if we denote n as the nodes in the first tree and m as the nodes in the second tree, then we basically have O of n plus m. And then the only other thing that we're doing really is comparing the two lists of leaves to each other. So that is going to basically process or visit or whatever every leaf node exactly once for each tree. So we could say like O of L or something, where L is the number of leaves in whatever tree we're in. But the number of leaves in the tree is always going to be less than the number of nodes in the tree, so this really doesn't matter. So we still would go with O of n plus n. So n is number of nodes in tree 1. Let's just do like that. M is number of nodes in tree 2. Okay, and then space. So let's think about space. So we have our two lists here, which each list is going to store the leaf nodes in each tree. And then we also have the call stack from our DFS. And so the call stack, worst case scenario, if our tree is just a straight line of, like, it's completely unbalanced, and it's a straight line where we only have right children or we only have left children, so it's basically like a linked list or something, then we will have O of n on the call stack at one time, like every single node on the call stack at one time before we can pop them all off, which if we account that for both trees would be O of n plus n. So that is going to be worse than just the leaf nodes, just the leaf nodes which we're storing in the lists here. So the call stack overrides that, so that's going to be O of n plus m as well. Oopsie. And yeah, so that's it for this problem. Thank you guys for watching, and I hope this was helpful. If it was, please like and subscribe. Bye!